we will solve this today's LeetCode problem. This is LeetCode medium one. This is number of wonderful string substrings. Let's see what it is. So here it is given a wonderful string is a string where at most one letter appears an odd number of times. For example, CCJJC and ABAB are wonderful, but AB is not. Why? Because in AB there are two letters which has occurring odd number of times. That is, A occurs one time and B occurred one time. So AB is not an wonderful substring, but CCJJC is a wonderful string, right? And ABAB is also wonderful string. So we have a given a word string which consists of first 10 lowercase letters. That means from A to J. We need to return the number of wonderful non-empty substrings in word. If the same substring appears multiple times in word, then count each occurrence separately. Okay. So we need to find the number of wonderful non-empty substrings in word, right? Okay. So if you see, we need to find total number of substrings which is wonderful, uh, and wonderful substring is the one which has don't have which have only at most one letter occurring in odd number of times. What does it mean? That either each letter occurs even times even times even times in substring, or only one of one characters occurred odd number of times odd number of times, and rest of the characters occurs even number of times. This is what at most one letter appears. It means, right, occurs even number of times. At most one means less than equals to one, either zero or one, maximum one, right? So this is the wonderful substring means here, right? Okay, we understood the question, right? Simply. So this we had to find this number of substrings. So the first approach which comes in my mind is sliding window, right? After seeing the substrings, the approach comes to sliding window, that whether we can use the sliding window to solve this problem or not. So let's see. In this ABA, what are the conditions for the sliding window, right? So in the sliding window approach, the problem is here that how we will find the fixed window find the fixed window size find the fixed window size. So can we find the fixed window size in sliding window in this case? So suppose here it is given AB, so if I see A here, it occurs one time. If I see AB here, we can't take AB because this occurs both at odd number of times. Both the characters occurs odd number of times, so we can't take AB, right? So if you don't fix the and if you start iterating from the first part, suppose I have taken I0 and J0, and I have started I taken I is equals to 1. It's we can take this simply, right? When we take AB at a time with AB as a combine, we can't take this because the number of characters which occurs odd number of times is greater than one, right? So what will we do in sliding window? We slide the windows because we are not met the condition which is given. So we slide the window and we shift this J to 1 now, right? So it will left to B with, right? So the problem with this is that this after this ABA can also be an answer, because A occurs two times and B occurs only one times. So ABA can also be an answer. ABAB can also be an answer. So the problem with the sliding approach is that we are not able to fix the window size here, right? So will not able to use the sliding window approach, right? So we will not able to use the sliding window approach. We are not able to use sliding window approach, right? Window approach. It means that we need to figure out something different approach. Okay. Now if again by taking seeing this example AB, if you see what is the problem here, the problem is here that suppose I'm standing at this index. The problem is here I don't know that at its previous values that how many times this current character occurs, how many times the different characters occurs previously before this. So how we will determine that whether this a is included in my substrings or in which substrings will this a included, right? So for this, what we need to do, we need to what we need to do, we need to somehow somehow we need to store the frequency of every characters which occurs till my current index, right? Till my current index. Somehow I need to figure out that how many frequencies of every characters occurs till this current index. Then only we can think of any approach, right? Okay. The first problem is this, right? The first thing is this. The second problem that we need to see that how many substrings, in how many substrings, and how many substrings this current index will be a part. So we need to see that this current index will be a part of in how many strings, right? In how many strings this current index will be a part of, right? We need to figure out this, right? So if you see, if you have solved the number of, if you have solved, if you have solved the number of, if you have solved the number of the number of subarrays for a some value, for a some values, for a specific some value, for a specific some value. If you have solved this problem for a specific some value, for the given some value, right? Value, you have used a map, hash map, right? You have used a hash map. So for counting the number of subarrays, the number of subarrays. So let's see, can we use this approach, hash map, for counting the number of subarrays? So for using this hash map, if you see here, suppose here it is given AB, 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 ABA. Let's take this example again. So if we started from AB and occurs again and again, so suppose here AB is here, then again AB, A, AB, AB, A, AB, 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 A, AB, 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 A. Okay, so this is the prefix of all this prefix of all the subarrays, right? This is prefix subarrays starting from A, right? So if we see here, is somehow I will determine that this AB occurs again at this AB, right? This AB is again occurring at this position, this AB. This AB is again occurring at this AB, right? This ABA is again occurring at this ABA, right? So if we somehow determine that the number of occurring substrings is even, because either each letter occurs even number of times or only a single character occur odd number of times, right? So if you see, and we need to also store the frequency of every characters till my current index, and every letters occurs even times and odd times. So if you have solved, if you have observed here, observe this even odd thing, uh, did you get any idea of XOR properties, right? So I have uh, I have told you XOR properties in my yesterday's problems. At what does this XOR properties does? So if evens or even occurs, then it becomes zero, right? If we XOR even numbers of times, it becomes zero, right? Sorry, not even number, XOR even number of even occurrences, XOR gives zero. And the same thing happens with odd. The opposite happens with odd. It gives one. So can we use this XOR value for this storing purpose? So let's see. Can we use this XOR properties? So if you see here, for every every different, for each different characters, can we store, can we take a different position of bits for every different character? Yes, we can take, because here only 10 characters given. Only 10 characters is given, right? Is given. So we can assign every positions for a different bits. So suppose here A assigned to 0, B assigned to 1, C assigned to 2. So suppose here ABC occurs, then its value will be 111. If A occurs, its value will be 1. If B occurs, its bit value will be 01, right? Sorry, 10. So this is how we will assign every characters to every positions. So this A will occurs at 0th index, B occurs with 1 index, C occurs with 2 index. So if ABC is present, then we will just flip the 0 to 1 value, right? We will just flip the 0 to 1 value, and we don't do anything else, just flip the 0 to 1 value, right? So now we will see that how we will use this bits manipulations using XOR value, right? So let's make you understand this, how we can use this XOR protect. Actually, this should not be a medium problem. I don't know how this is medium problem, because and thinking this approach is something difficult to understand for a medium level. But yeah, let's see. It's less than a hard but greater than medium, right? It's a less than hard and greater than medium problem. So suppose here this is A. For this, the mask value is 000, right? This AB value is, for AB this will be 010, sorry, 011 for ABA. So for ABA, what will be the mask value? So A position is 0th and B position is 1th. So that will be 1, but this A occurs 2 times. That means even times. And we know that even occurrences give XOR 0, right? So at position 8th, it will give me 0. Understood, right? So again for this AB, that will give me 00. No, because A occurs even times and B occurs also even times. For ABA, it will give me 01, because A occurs 3 times, B occurs 2 times. For ABA, it will give me 00 again, because B occurs 2 times and A occurs 4 times, which is even. So if you see here, this 00, this 00, this 01, this 00 is occurring 2 times here, right? It means this ABAB and this ABABA, this ABABAA can contain this ABAB as a substring value. It means if I started from 0 to J, if I started 0 to J here, and if I also take from 0 to I, where I is my current index. So if the mask is, if this bit value, let's call it the mask. So if this mask value is same for 0 to I, 0 to I and 0 to j, it means that there is an even number of characters occur between j and I. No, see here, this ABABA and ABABA, between this B and this last character A, this AA occurs two times. It means it is an even characters. So we will we can take this j to I for every each and every character between this j to I, right? We can take that every even characters between this j to I. Videos, I don't know what happened, that videos not uploading fully, so I am making another video. I've already explained written this in my previous to explain you all these approaches. So here's the thing, that the mask which is present already between 0 to I and the 0 to j, it means that there is an even number of characters occurs between j to I, right? So the same goes for the odd occurrences of time. So for when only one odd occurrence of one characters occurs, so my claim is here that I will there will be only a one bit difference between masks, right? So suppose here you take AB and AB examples, right? AB and BA. So his mask is 0 1, right? And when this 0 1, and I will check each and every characters from letter A to J with this mask to check that whether the new mask which occurs is already present in my previous one or not. If that is present in my previous one, it means that the only one odd occurrence of one characters is present here, and we will include in my answer. Just see here, this ABABA example, this 0 1, when I take this XOR with A characters, it becomes a new mask which is 0 0. So this 0 0 is occurs at my positions. This 0 0 will occur at my positions which is at stored at 1. So this will form an occurrence, because this will give me a 0 0, and this A is only and this only the this A characters occurs odd number of times, right? So this will be my answer. When we take a XOR with B, it becomes 1 1, which is not present in my previous mask. So this will not be an answer. And you can also see that this ABA has one characters with this, so this will not give me an answer with B dot, right? So the same thing occurs with one occurrence. Only the difference is here that the mask has only a one bit difference at any positions, right? So the number of masks which occurs at previously will be the same according to this, right? The same thing is happened with the first one and the second one. Only the difference is the only one difference between mask is different, right? So if you see what will the my approach here. So first we will assign each and every character to a specific position in bits binary, right? Binary representation in bits. So there are only 10 characters, so it is possible to assign each and every character to a specific bit, right? Such that a to 1, b to a to 0, b to 1, c to 2, this position, right? So that I can make a mask of every characters again and again. Now the second thing is, we will make a mask. We will make the mask starting from the zeroth index and continue it till making from to n, and we will simply check that whether this mask is already occurred previously or not. So if it is present, then it means we have an even number of characters which occurs evenly. So it means we will include in my answer this mask, how many times this mask occurs, it will be in my answer. And the same mask and the if and for checking the single odd occurrence of one character, we need to take a XOR check with the each character from A to J with that mask. If after taking XOR check with that mask with every character, if that mask is occurring previously in my answer, then I will include that also. That's how I will check that there is a character with there is only one character with at most one odd occurrences in my substring, right? So this will be the approach here. So let's see how we will implement this. So first thing, I will make a mask variable, and I will also take a unordered map to store the count of mask occurrence. I will store this 0 as a 1 to suppose why this is happening, because it will give me the answer for the first occurrence. Suppose here it is AB, right? So suppose this AB is here, so its occurrence is 0, its mask is 0 0. Suppose this AB has occurrence of 0 0, and I am not, if I don't include this 0 to 1, so this substring will be get neglected if I don't include this in mass, right? So for this purpose, I need to include at a starting point to 1, right? So now what I will do, I will start taking a mask for this. So what this is doing? Suppose I have started taking mask value. So this word I minus a will suppose this is 2 value. When I left shift 2, it will becomes 100, right? And when I take this 00 zord with 1 left 1, it will become 110. And again like this, if I take this zord with 100, it will become 111. So this is same thing happening is here in mask value. So that's why I'm taking zord value with mask to make all the characters at every positions by left shifting this, right? And whenever this mask occurs previously, I will store in my answer. And for checking one odd occurrence character, I need to check for every character from A to J by taking a new mask. And if that new mask occurs in my previous, it means that there is a substring which has one occurrence of characters or times. So I need to again add this new mask value, and I will store the count of mask which is present here, right? And we will simply return answer. This is the how I implement that. So the time complexity and the space complexity, if we see, that will be O of n, because the time complexity we need to iterate in whole of the string value, right? And also that inside of this we had iterating from for every checking for every characters which is 10 characters. So that will be O of 10 into n, which is ultimately equals to O of n. And the space complexity will be, so the number of different number of unique keys can be possible is 2 to the power 10, because the total number of variables combinations and permutations of every bit from 0 to 10 will be 2 to the power 10, which is 1024. So at most 1024 unique keys will be in map. So that will give me, so that can be the space complexity in the worst case. So this is how we will solve this problem. uh, Somehow I don't know how that video get stuck in between. That's why I need to make another video. So I hope so that you understood this problem. Just just take a pen and paper and try to you do this. You will be clearly understand, right? Thank you.